Hello, everyone. I am Mr. Shen Lewei. Today, we are going to learn the course of Water Pollution Control Technology, Module 4, Section 3 of Advanced Treatment Technology Membrane Separation Technology. The membrane separation technology we are going to learn today. He also made some contributions to the construction of our Navy. It solves the problem of water shortage for officers and men of ocean-going ships. In August 2010, on the occasion of the 50th anniversary of the establishment of the North, an old chief recalled that when he went to Nansha with the first-generation destroyer to perform his mission, he said, "The most unbearable thing is the lack of fresh water. Everyone is allowed to wash with only 1 cup of tea every day. No matter how hot it is, no matter how sweaty it is, there is no cold water to shower. Most cadres and soldiers are covered with prickly heat, which is extremely itchy. I can't bear to peel off my skin when I can't bear it." But since the ship was equipped with seawater desalination equipment, the officers and men just bid farewell to the problem of water shortage. The core technology of seawater desalination equipment is to adopt reverse osmosis composite membrane module, separate the salt from seawater, achieve the purpose of seawater desalination. After seawater desalination, it is like purified water in the home. It is drinkable. Membrane separation is a precise separation technology. Molecular filtering can be realized. It takes advantage of the selective permeability of membrane pores. Technology for two-phase separation. The pressure difference between the two sides of the membrane is used as the driving force, permeating solvents, inorganic ions, small molecules, etc. through the membrane, while intercepting particles and macromolecules. The process of separation is similar to that of workers sifting sand on construction sites. Fine sand can pass through the mesh of the screen and fall into the sand bucket. The coarse sand is larger than the mesh and is intercepted by the mesh, so that fine sand and coarse sand are separate. The structure of membrane is similar to that of screen, but the membrane hole is much smaller than the screen. There are many kinds and functions of membranes, so there are many classification methods. According to the material, structure, shape, separation mechanism of membrane, separation process and pore size are classified. It can be divided into organic membrane and inorganic membrane according to different materials. According to the structure of membrane, it can be divided into symmetrical membrane, asymmetrical membrane and composite membrane. According to the shape of membrane, it can be divided into flat membrane, tubular membrane, hollow fiber membrane and rolled membrane. According to the pore size, the membranes can be divided into microfiltration membrane, ultrafiltration membrane, nanofiltration membrane and reverse osmosis membrane. Because of the pore size of the membrane, it is closely related to the removal of pollutants in water treatment process. Even to a certain extent, it affects the removal effect of pollutants. So let's focus on microfiltration, ultrafiltration, sodium filtration and reverse osmosis membranes. Microfiltration is also called micropore filtration. The porous membrane is used as the filter medium. Under certain pressure, sand, silt, clay and other particles in solution, and substances larger than the pore size of the membrane, such as Giardia, Cryptosporidium, algae and bacteria, were intercepted, while a large amount of solvents, small molecules and a small amount of macromolecular solutes permeate the membrane, so as to realize the separation of particles in raw water and filtered water. Microfiltration membrane belongs to porous membrane. The pore size generally ranges from 0.1 micron to 10 microns. Filtration principle belongs to screening mechanism. That is to say, it can intercept all particles, fibers and suspended solids larger than the mesh. The operating pressure of microfiltration process is generally about 0.01 to 0.2 megapascals. In the process of water refining, microfiltration technology can remove bacteria and solid impurities. It can be used in the production of medicine and drinking water. In the preparation of ultrapure water in electronic industry, microfiltration can be used as pretreatment for ultrafiltration and reverse osmosis, and terminal security filtering of products. Microfiltration technology can be used to filter beer, rice wine, and other alcoholic beverages, to remove yeast, mold, and other microorganisms, clarify the product, and extend the storage life. Microfiltration technology is also widely used in drug sterilization, biological detection, and other fields. Ultrafiltration is a low-pressure membrane separation technology. Under certain pressure, small molecular solutes and solvents are made, special film passing through a certain pore size, so that the macromolecular solute cannot be penetrated and remains on one side of the membrane, so that the macromolecular substances are partially purified. Compared with microfiltration membrane, ultrafiltration membrane, its structure is more asymmetric. There are many materials that can make ultrafiltration membranes. There are various types and specifications of membranes. The micropore of ultrafiltration membrane is less than 0.1 micron. It can completely filter out harmful substances such as bacteria, rust, and colloid in water, retain the original trace elements and minerals in the water. The ultrafiltration membrane module can be divided into tubular membrane modules from the structural unit, that is, plate membrane module. Ultrafiltration technology has the following advantages. First, the ultrafiltration process is carried out at room temperature. The conditions are mild and there is no component damage. Therefore, it is especially suitable for heat-sensitive substances. For example, the separation, classification, concentration and enrichment of drugs, enzymes, and fruit juices. Secondly, the ultrafiltration process does not change phase and does not need heating. Low energy consumption, no need to add chemical reagents, and no pollution. It is an energy-saving and environment-friendly separation technology. Thirdly, ultrafiltration technology has very high separation efficiency. It is very effective for the recovery of trace components in dilute solution and the concentration of low-concentration solution. Fourthly, the ultrafiltration process only uses pressure as the power of membrane separation. Therefore, the separating device is simple, the flow is short, and the operation is simple, easy to control and maintain. Ultrafiltration technology has developed rapidly. It is widely used in municipal sewage treatment and reuse, seawater desalination, and other industries. Nanofiltration is a pressure-driven membrane separation process between reverse osmosis and ultrafiltration. The pore size of nanofiltration membrane is about several nanometers. Compared with other pressure-driven membrane separation processes, nanofiltration membrane appeared late, but it is developing rapidly. The operating pressure of nanofiltration is lower than that of reverse osmosis. Therefore, nanofiltration is also called low-pressure reverse osmosis or loose reverse osmosis. The pore size of nanofiltration membrane is relatively small, usually only about 1 to 2 nanometers. The molecular weight cutoff is in the range of 80 to 1000 Daltons. It has a certain rejection rate for inorganic salts. At present, most nanofiltration membranes are aromatic and polyacid hydrogen composite nanofiltration membranes. The forms of nanofiltration membrane modules are hollow fiber, roll type, plate frame type, and tube type, etc. The packing density of hollow fiber and roll membrane module is higher. The cost is low and the hydrodynamic conditions in the assembly are good. Therefore, hollow fiber or roll membrane modules are often used in nanofiltration systems. Nanofiltration separation is more and more widely used in drinking water purification, sewage treatment, and other industries. For example, the preparation of ultrapure water, the removal of groundwater hardness and other processes. The operating pressure of nanofiltration is usually 0.1 to 1 megapascal. The rejection effect of monovalent ions and organic matter with molecular weight lower than 200 is poor. For divalent or multivalent ions and organic compounds with molecular weights between 200 and 500, high removal efficiency. Based on this characteristic, nanofiltration is mainly used for softening and purifying water, and the separation, decolorization and odor removal of substances with relative molecular weight of 100. It is mainly used to remove hardness, odor and chroma of drinking water, pesticides, synthetic detergents, soluble organic compounds, and removal of evaporation residues, etc. Reverse osmosis is also called reverse osmosis, is a kind of pressure difference as the driving force. Membrane separation operation for separating solvent from solution. Because it is opposite to the direction of natural infiltration, so it is called reverse osmosis. The principle of reverse osmosis technology is that under the action of higher osmotic pressure than solution, according to the fact that some solutes cannot penetrate the semi-permeable membrane, and take these substances and water away. Reverse osmosis is made of a semi-permeable membrane simulating biology. Artificial semi-permeable membrane with certain characteristics. The pore size of reverse osmosis membrane is as small as nanometer. The filtration accuracy is about 0.0001 micron. That is, about 0.1 nanometer. It is a very fine membrane separation product. Industrial reverse osmosis membrane modules are in the form of plate frame type, tube type, hollow fiber type, spiral coil type and capillary type, and 6 types of slot bar. Current reverse osmosis technology. It has developed into a modern membrane separation technology which is widely used in the desalination of seawater and brackish water, ultrapure water preparation, wastewater treatment and so on. Reverse osmosis technology has incomparable advantages over other methods: microfiltration, ultrafiltration, nanofiltration and reverse osmosis. These 4 types of membrane separation technologies, they all play an important role in the water treatment process. Widely used in terminal filtration of various water treatment, pre-treatment of industrial feed water and treatment of drinking water. In practical engineering, which type of membrane module should be used? It should be selected according to the characteristics, concentration and treatment degree of pollutants. Alright, everybody. Today we mainly studied membrane separation and related knowledge. This concludes the study of this chapter. Thank you all.